this presentation.
Thanks guys, thanks for coming. So I'm Mithun, I work for Amazon. And this talk is about how we apply machine learning and software testing space. This is a very evolving space. It has just started grabbing attention of even academic research. So let me put an attempt to have a basic understanding of where the space is leading and then what we are currently doing, how we can contribute to it. So that's what this talk is all about. Let's start with it. Let me start with one question. Thus, identify the movie. What? Inception? Imitation game. Anything else? Okay, identify the gentleman. Alan Turing. No, it's not Alan Turing in the movie. Okay, right. So, why are we speaking of Alan Turing in machine learning? Any idea? Any answers? We like the movie, yeah. I like the movie. Yeah, I do like the movie. Anything else?
He is the first one to develop this permutation combination machine.
Right? Great. Anything else? So he was the first one to develop permutations on this. Basically, he was the one who thought of a machine which can learn based on how we teach it. So he conceptualized a computer as a small machine, as a baby, where we can teach it and it can improve over its space. So none others apart from him thought in that way. For example, when you would have watched the movie, you would have come to know Germans. They came up with a mission, and then we wanted to invade it. I mean, we in the sense from UK. So they wanted to intercept it. They had no other way apart from inventing another mission. When it was being done in a manual way, it was quite difficult. So he came up with teaching the mission. So this part, having something where the machine can learn from you, is what is quite important to us. So can we teach the machine? So that's what the subject is all about. It has come a long way since 1950s when Alan Turing conceptualized it. Right now, where we are. So according to Tom Mitchell, it's like it's a space where we study computer algorithms and then it can learn from experience over a period of time and it can improvise itself. So we are bringing intelligence into computers where it can evolve on its own. So this is what the space is all about. So for instance, have you watched this? I'm not sure if it's visible. It says customers who bought this also bought. Right? So if you got a chance to explore or shop on Amazon, you would find this recommendation engine which shows up after you purchase or even while you are on a product page saying that you can also try this. Probably you might be interested. So this is not some random books which are being displayed to you. Rather, it's based on a study on what others are also perceiving in the same age group on similar factors, and then the algorithm predicts that probably you would also fit into the space. So this is one of the easiest examples that we can think of in learning machines. Another easier one is this. You would have seen this. If you're using Gmail, you would see that if you're going to mark something as spam, going forward, if you receive a mail from the same sender, it would probably itself apply the spam filter and it would move to the spam folder, right? So this is also being taken care. It's not only based on how you're going to categorize whether a mail is a spam or not. It's also based on who the sender is, what the IP is, what others perceive about the sender. So all these play an important role in Gmail taking this action that this mail belongs to a spam. So on, we have similar other activities where machine learning can play a part. When you look at how the programming space has been until now, so you typically have some data and you have some program. So you write a class and then this class might have some functions where it can take in some data and it can give an output churning out of it. So you have some computer which can take program data and gives output. So this has been the typical programming experience that we have undergone as of now. But machine learning goes the other way around. So this output also become an input. So we look at the output that what we have got over a period of time. So for example, if it's a Gmail spam engine, we look at what are the mails which are categorized as spam, and then we take this output as also an input into the computer. And then we come up with program. So we are not actually teaching the computer how to program. I mean, you might have seen aircrafts which fly over without having any manual intervention. So we are not actually programming it. It's quite difficult for us to teach it how to fly. Rather, it learns on its own based on the input data that we are giving to it. This input is the historical data. So we look at historical data, and then we actually give a test input, and then we look at how it can program itself. So this is where the entire space is about with machine learning. When we look at how this works, so we have some training data. These are the historical data like person A, person B, person C. All these have given saying that this is a spam, and then we give some test data like person Z comes in and then says, I have got a mail from xyz@abc.com. Is this a spam? Probably this learning machine has learned by now saying that yeah, it must probably be a spam, and then it categorizes for prediction. So it predicts automatically saying that yeah, move it to spam filter, or no, this is not a spam filter. Again, this would be an input. This would go into the training data going forward. So we would have even this set of data going into the training. So this space evolves gradually over a period of time. Now let's look at how we can fit into this space with software testing. As I told you before, this has been an evolving space. The researchers have just started to research on how it can be applied to code bases. It has been very limited to the customer section, where they think about having spam filters or recommendation engine and so on. But can it work at code level is what currently it's being experimented on. When you look at the software test lifecycle, we have pre-execution, execution, and the post-execution phase, which we normally know, and which we have seen that probably we do some test planning, some code reviews during the pre-execution, and also we would be scripting test cases if we need to, be it manual or automated. And then we might do some automated runs during execution, and then we might run the test cases during execution, and then we also do defect analysis. So that is also part of your execution phase. And coming to post-execution, we might do some debugging if there are any defects logged, and then we also would update the regression suite. So these are the set of activities, and when you look at the entire set of activities, are we applying automation anywhere? Are we using automated tools anywhere? Probably during the execution phase. Only for execution we might be using, say, Selenium, Calabash, or any other tool, be it open source or commercial tools. We might be using it during execution phase. Maybe some tools which are not completely automated, but which can act as a repository for your pre-execution and post-execution phase. So this has been the scope of automation right now, what we are using for our software test lifecycle. Now, how can this change? So in terms of software testing, we see that it's a critical task in the entire SDLC. We also do overspend of time as well as resources when it comes to software testing. According to your research, we overspend up to 90% of our time just because there is some bottleneck found during our testing phase, and there is a lot of manual intervention in the entire process. So automation has been limited to a very small scope of execution only. We don't really use it for pre-execution and post-execution. So this is what the entire problem space is. So we have defined this as the problem space, that we want to have some automation at the pre-execution and the post-execution phase. Can machine learning help us? Now let's have a look at some common or some basics of machine learning, few common algorithms. So we can categorize learning into different steps, but for the sake of ease, let's look at few of the learning which is supervised learning. It's similar to what we saw earlier. We have some historical data that we are giving to it, and we also categorize certain labels, and then we give it to the learning algorithm. And whenever there is a new text or document which is given to this machine, it predicts the model saying that what should be the categorization for this new text data, depending on what the historical data has been. So this is based on what we already know. So this is supervised learning. And the opposite of this would be unsupervised learning. Even that is machine learning. So unsupervised learning, where we don't have any set of labels given to the filters. So for example, I'm not categorizing it as whether it's a Gmail spam or not within whatever execution that I'm doing. I still might have some historical data, but this might not always be present. So we would still need to predict, even when there is no historical data, how is this possible? Again, we have a new test document which is given to the learning machine, and then which needs to predict and give us what the output is. So this is what the few categories of machine learning. I'm not going into other algorithms. Let's only concentrate on these two, probably for our understanding into how this could fit into the space. Now let's go back to the software test lifecycle. So we have pre-execution, execution, and the post-execution phase that we have already seen. Now looking at these activities, probably we can think of these areas like software defect prediction. I'm not saying about prevention, rather it's the prediction, and then probably taking remedial action even before the software is given into the execution phase. So in the pre-execution phase itself, can you find some software defects? So that's the first problem which we are probably trying to tackle. The next is about the test planning. So we spend a lot of time in knowing about what is our critical path, what should be the software development life cycle that we should be following, whether it should be agile, and then how should QA resources fit in, what is the cost involved. We also overspend this. Our estimation has certain limitation which is beyond the scope. So we are taking into consideration of any historical data that can probably be helpful to us. And then we look also into test case management. This has been a very debated area, whether we should be scripting the tests. I mean, the manual test cases, should we write it, or whether it should be context dependent, where we come up with exploratory techniques and then we write it on the fly, and so on. So this has been an area where there are different schools of thought. People argue that we should go with scripted testing, and some people do with context testing. But the overall challenge is, are we really updating our regression suite? We normally do not do. Even if we do it, it has been to a very limited extent. So can we apply something in this space as well on test case management? That is another area which we are probably going to see. And then we look at debugging. After a defect has been found, can we take any remedial action on the debugging part? So this is again another part which probably we can explore using machine learning. When we look at the algorithm, a little bit into Bayesian algorithm, which is being used for something which we already know. So if we have some historical data, yes, any question? Okay. If we have some historical data, probably we can apply. It's a very simple algorithm. It's one of the basic algorithms in machine learning, where we have some. We look at the probability of occurrence of a certain event C, given we have a set of data which is ranging from 0 to n. So we have a range of data, and then we look at the range, and then we calculate what is the probability that an event can occur. Now this might be a little confusing. Let's not look into what the formula is. Rather, let's look at some example. Now this is an example where we have plotted x with x1 with x2, or x with y. Let's assume that we have some historical data saying that if x1 is here, x2 is here. So we have got one set of data. Similarly, we have plotted for this, and it goes on. So we have got a historical plot of what happens with x2 when x1 is over with x1 over a period of time. When we look at this, what really happens is we get the plot which can be plotted onto x1 alone, and then we have a set of test data. Let's say that we got a test data saying that my plot, my actual test data that I'm going to supply to the learning machine would be here. So I would be taking into consideration what the historical data of this has been. Let's assume for the sake of ease that all these are say cancerous cell and these are non-cancerous cell. So you have found a cell and the doctor want to confirm whether the cell that has been found probably during MRI scan, whether it's cancerous or not. So what probably we apply machine learning is, we look at where the cell would lie, and this is the size of cell, let's say, and this depends on whether it's a cancerous one or not. Now we would be looking here, and then probably looking at this data, we might be considering that it might not be cancerous, looking at the probability. Now, to apply it into our software testing space, let's look at a simple white box testing where we have, let's say, the branch count as 5 and which increments over a period of time, and then we have the number of lines of code. It's a very small program, but in reality it might not be as simple as this with just 5 branch count and 15 lines of code. So when you look at this, we have some historical data saying that whether product is defective or not. So with a branch count of 5 and 15 lines of code, the product was not defective, and with 15 as branch count and 40 as lines of code, we see that the product was defective. So this is the historical data that what we have received. Now when we apply it to the classification technique, that what we saw in the previous example, so we looked at this graph and then we plotted this. Now it's easy for us, we looked at the branch count, maybe let's take that as x1, and then the number of lines of code as x2, and then we plotted saying that whether it's defective or not. So all these red ones probably it's not defective and the blue ones are defective, let's say. Then we would be probably given this example. Now we have a newer set of data into our problem saying that my line of code is 39 and I have 16 as the branch count. Is this going to be a defective product or not? So we are going to use this machine to know whether it's a defective product. Applying Bayesian algorithm, we come up with a probability saying that the no probability is this 0.0000009. So it's 9.1 into 10 to the power of minus 7, and then yes, it will be 0.0181. It would be 1.81 into 10 to the power of minus 2. So looking at this, we look at probably this is going to be a defective product because the probability of lying in this space is much higher. So we are not actually going to plot this graph. It's going to be taken care by the computer which is going to predict for us. Rather, our problem space is only in looking at what the historical data is and then feeding it according to the right algorithm. So here we have selected Bayesian algorithm for our analysis. So this is one of the ways in which we would be going with software defect prediction based on the white box technique. Now when we look at the other problem space, any questions till now? Yes.
How do you manage with, how do you deal with the set of data changes in between the process?
Right. So you mean that this becomes 16 over a period of time?
Given an example about the defective cells and the healthy cells.
Right.
As the time proceeds,
right,
the number of defective cells grows.
Right.
In case if there is no medication in between.
Correct. So we are only taking it at a certain instance. Say a person comes at 6 months of probable cancer prediction, and then at 6 months period of time, we freeze that and then we look at this graph. So similarly, for our historical analysis, we would assume that this product has been frozen and we are not making any further code changes. So the number of lines of code and branch count is going to remain same. So we are not going to again expand the product further. If there is expansion, we will take it as another historical data going forward. Did I answer you?
Are you making the prediction using Bayes theorem or are you using...
This is Gaussian.
No, are you using linear regression or are you using Bayes theorem?
I'm using Bayes theorem.
But how can you do a prediction using Bayes theorem?
No, here what I have used is Gaussian analysis.
No, are you calculating probabilities using Bayes theorem?
Yeah, probability using Bayes theorem.
And then using linear regression to do predictions?
Yeah, linear regression to use prediction. Now let's look at linear regression for finding defect density, a very similar one. Again, we have a plot. Now this is age in years, and what is the height in meters? So this we have received from historical data looking at kids between 2 to 8 years age. Now we look at what their height is at various instances, and then we plot it, saying that a person with 2 years age is probably 0.75, and then we get a set of plots in a graph. Now looking at this, if I give a problem saying that what is something which lies here, say at 4 years or 4.5 years, what is going to be the height of this person? Now when we look at this, we would be probably predicting that it might be 1, or the range can extend between 1.05 or it can be somewhere around 0.95. So this can be the range, and the only way in which we can eliminate such errors could be in looking at the most probable data and then eliminating all the excluding few of the outputs so that it's easy for our statistical analysis. So this is one of the way in which linear regression could be done. So applying this, probably we find that this might be the linear path, and then we might be taking that the person's height should probably be 1.05. Now when we look at a similar example on the number of lines of code with defect density, we might also be able to predict what might be the defect density based on the historical data of the similar training set that what we have received earlier. When we look at the test planning phase, we have seen that our major challenge is at looking at the estimates that we provide, so that we don't overspend it, right? So using the same analysis, we can also look at what the complexity of your problem is going to be, and then we can probably look at cost estimates, and this is one of the easiest way in which you can go for the cost estimate of your product. So we look for database formation, data collection, and then we go with classification of your software and analyzing the results. So thereby you come up with a cost prediction, which has been successfully implemented in various companies. Now when we look at the other phase in pre-execution, which is about writing test cases. So work has been done. All the references are given. I'll share the slide with you so you can take it up later. So there has been an analysis with a program called machine learning based refinement of black box specification. So here we don't have the number of lines of code or the branch count or the defect density as such. So let's assume that it's a black box for us, and we are given few test cases which is going to evolve over a period of time. So we might want to predict what are the use cases which can be used in our system based on the historical data. So we have a regression suite which is performed by project A, project B, and then can it be used for project C? So we need not rewrite anything. So for this, what we have, what this research has been is into, we generate the abstract test suite based on several keywords, and then we have historical data, and then there is decision tree, which is like if-else statement, and then we look at, so these are completely automated ones, and then few are partially automated, like analysis of decision tree and so on. And we pick the updated test suite, and then we update the regression suite. Again, this goes into the abstract test suite. So thereby we create a continuous cycle whereby we can update the regression suite as and when it's required. Overall, coming to the classification, it might not be clearly visible. So this is from a paper on classification algorithm. So we can either go with black box, white box, or gray box as the testing approaches, and depending on the problem space that we want to tackle, we might be going with various machine learning technique. So it might be decision tree analysis or artificial neural analysis and so on. So we have different set of learning techniques, and we just saw pretty basic ones, which might not be sufficient for our analysis in real-time activities, but we might be able to use any of these activities at various test levels, be it unit level or system level or acceptance level. We might be able to use it, and then it can also cater to various of these activities like test planning, test case management, debugging and so on. So we have seen various examples on how this could be applied, and we might be using the various historical data that we have received from our company. In case if we don't have any historical data, how do we tackle this problem? This is one of the biggest challenge that most of the companies would have. We might not have any historical data, since we were not concentrating on what is the effect that is going to be for certain lines of code, or what might be the black box technique that we are going to use. So the easiest solution that you can go with is abstracting your entire software so that it can be reused across companies. Normally companies do not share their code base and also their effect strategies, their testing strategies and so on. So one of the easiest way in which you can go is with a publicly available data set, like NASA for example, it shares its data set. So you can probably look at the data set which is provided by NASA, and apart from that you also have several test data. So an easier solution for you to look at is WEKA, WEKA. So you can search for it, WEKA, WEKA. So this also has certain training data sets which you can probably use for your organization when you are going with it. So several challenges that the first solution is looking at the past data availability. So you can probably look at these areas like WEKA, NASA, and then look for McCabe's cyclomatic complexity. If someone has shared in their organization, this can also be useful. And then look at the predictable pattern. Are we looking at something which we can probably look into? For example, no one thought about looking for predictability in test cases, but someone thought later and then they applied it there. So there might be areas where even you can apply machine learning into your problem space. So the steps forward would be how to completely use into black box technique. So right now it's been very limited to white box techniques and like linear regression or classification technique. So how to use it for complete black box? Can it be used to aid in faster delivery of the product with all the software testers? So this is one big research area which is waiting. And then finding the right pattern. It might not be right to say that whatever worked for NASA might work for even for me. So we might need to use appropriate predictability techniques. So that's another way forward that what we have. And algorithm analysis, again, this has been very limited. The reason being software testers are not really involved in these prediction. It has been only at the academic level which has happened. So I would always suggest that industry practitioners like you come forward, take up this problem space so that we get more analysis into what the current pattern is with your organization, which you can transfer it to other orgs, and then you can also receive looking at the predictability. So this makes delivery of software quite easier. And then upcoming areas, crowdsourcing. So in case you are one of the companies which has beta testing by giving out to crowd and then doing some crowdsourcing in terms of testing, probably that's one of the area in which you can handle more amount of data. Probably you would need to set the configuration to look at what your test cases are, what the test data this crowd is using and so on. So this can be another area which probably you can go ahead with. So this is my ID. Questions please.
Yeah, so my question is like, you can predict with using different types of models. We have tools to predict what kind of data we can consider. Let's say if I want to predict the test cases, right? So I'm not sure of what kind of data I can actually consider for the predict the test cases,
Right.
build the model.
Okay. For test cases, let's say, now we have some let's take a very small screen which has this username and password, and then we are going to type a username and password. So that's our test case. Let's assume that. Now we have a class which is going to say that for the username field, I have a class name, and then for the password field, I have some other class which is taking care of password. Based on these keywords, username and password, has it occurred in any other test suite that we already have? If so, what is the relevance with respect to the field? For example, it might be username password for banking application which might not be relevant here. So we might need to look at the relevancy and then probably look at linear regression for us to see what is the probability that it is going to suit our requirement, and then look at keywords. So in terms of keywords, what would really come is, for example, let me share you an instance of how Amazon classifies it. You have a book which is given to you, and then you have a Kindle book as well, a digital book. You have a physical and a digital book. So when you are going to read it, you use annotation to define whether it's a place name or a person name. So how do you define whether it's a place or a person name? So anything which precedes with a keyword at, it might be a place, right? Anything which might have he or she or they in the sentence, it might be a prediction. So all these are different prediction technology saying that this might be a person's name. So he is Mithun. So we are considering he is probably the keyword for us to determine whatever comes in the word as a noun, probably that might be a prediction model. So similarly, applying for our username and password field, we might be looking at, is there something known as username? Are there some common pattern which we can apply between the historical data and the current test data that I am supplying, and then can we do any sort of analysis using it? So that would be one of the ways in which we can.
So this seems to be a lot of work in terms of collecting data, making sure it's in the right context and putting it in the right perspective for the product under test. In which cases or which scenarios should we be using this technique or looking at these techniques to solve some of the problems?
So one of the basic areas which we can immediately apply is looking at software defect prediction. So that's one way going forward. As I told you, black box techniques, the algorithms are not very stable. There has been not many research, and then we don't have historical data for us to even go ahead with it. But if you want to start immediately on any of your projects, probably you can install Baker software. It's an open source one. So have some training set of data into it, and then look at how you can do defect prediction based on some historical data that you already have. Like the example that I shared with you, the number of lines of code with the defect density. So this training set is already there in open source. So use it and then look at how you can also abstract your classes and functions into the number of lines of code and the branch count. It's quite easy to get a branch count. So use that and then look at what your defect density is going to be. And then this will give you an easier way of estimation to know how long your testing phase is going to look like and what might be the test function that you want to like. I would recommend that for immediately starting with it, look for something which is already available open source, but also make it a point that in your own organization have some set of historical data which is being trended over a period of time. So it might not be immediately useful to you, but over a period of time it will definitely be handy whenever you are going to do any defect prediction based on this.
Thanks. One other question. You mentioned that this technique will be applicable or will work on sort of stable code basis when you apply this model. A lot of us, if not most, are working in the agile methodology where code is changing very fast. Does it mean that this is not going to be applicable in the agile space?
Definitely not. I would still look at this agile space as something in terms of function points. So rather than looking at the number of lines of code where it might change, look at what my use cases are. Maybe at use case level, I might be having certain use case which might be frozen or initially, which might not be changing as rapidly as the code itself. So maybe certain use cases will change, but look at the use case level, and the easier way that you can look at is also at the function point level. So use function points for your analysis. Again, we have this data for function points which probably can be used. Any other questions? Yes.
But use cases might differ from project to project, right? How would you
So here we are not looking at the quantity per se. I mean, we are just looking at the quantity, not the exact reference between the use cases. So we look at say there are 5 use cases to it, and then there might be 10 function points for a particular use case. Then we look at the number of function points. It's easier for us only to plot it. We need it only for training our machine, saying that for these many function points, this might be the estimate that what we are going to give. So convert it into something which is common across all the software database. So avoid something which is very specific. For example, something which works on healthcare domain might not work on retail domain. So what is common across these two is maybe the function points or the number of lines of code. So have something common between different domains so that you compare apples with apples and not otherwise.
Have we used it practically in any projects?
Yeah, we do have. So I have a list of references. Maybe that would act as easier guide.
What is the margin of error?
The margin of error. So right now it's been very shaky as such. I would say that.
And statistically, what is the confidence interval?
Say it's around 50 to 60% right now. It's not. It's been evolving as such. So depending on the space that what we are looking at. For instance, if it's a very if it's a problem space which has good number of predictions, where we know all the historical data which is very limited to it, then we are quite sure that our predictions are quite stable. We are excluding certain set of data which might not fall under. So the margin of error is very less. But when we are starting up upfront,
what is that value?
So somewhere around 0.9 is the probability which we have found. 0.92 I guess.
Because if it is 50%,
yeah, for brand new projects, it might not be even sellable to the management as such. But looking at how the algorithms are evolving over a period, we can probably see that it might expand.
So you also tune your regression model.
Yes, we do.
So some of the variables you fed in,
Yeah.
if they're not significant,
If they are not significant, we do.
If you have further questions, please feel free to catch up Mithun after the talk. Thanks, Mithun, for the presentation.
Thank you.
As a token of gratitude, we would like to present you a small video.
Good morning. Thank you. So, are you guys having a great time learning? And up for another round of dose of technical stack that I'm going to talk about. Right? Okay. So, in today's presentation, I'm going to talk about the Polymer framework, and how we are going to automate the Polymer framework-based applications. So before we start, let me take a feel from everyone. How many of you are dev and QA wire, or it's the QA community around? Okay. So this will help me to monitor the talk in terms of QA. The takeaway for all of you would be from this session to understand what the Polymer is, and how do you develop web components using Polymer framework. In case you want to unit test those components, if Polymer provides a framework or not. And we'll talk about how do you do functional testing using Selenium. Okay? So, before I start with the slides and the agenda, okay, I actually wanted to show you the application which is developed using Polymer framework, how it looks like. So, this will give you an idea that any application which is developed using Polymer is very UI intensive applications. So you may want to use Polymer framework for developing such applications. So I'll just do some quick navigation to show you the effects. Right? So you see all of these JavaScript manipulations and the style sheets that are being used, because a lot of effort in maintaining and creating those, right? So in a conventional framework, if you look at, you have to write and manage a lot of style sheets and JavaScripts to do that. So don't you always feel that there should be a framework to ease this effort of maintaining all of this, all of the resources that are being used? So we already have a lot of frameworks available, like the AngularJS, the Dojo Toolkit, JavaScript frameworks. Then 2011, Facebook came up with React framework, which is again on web components. In spite of having all of these frameworks, and they were typically addressing some needs, Google in 2014 started Polymer framework, which was very very relevant and gaining momentum because of two major things. One was the data binding, the other one was your reusability. So I'm just moving back to the slides. So that's where we are going to talk about the. We're not going to look at the comparison of the previous framework and what Google framework provides, but then we'll limit the talk only to Polymer framework. So the agenda for the entire session would be, we'll talk about the Polymer framework and how do we create web components, and then we'll jump over to unit testing web components, and then we'll look at how do we write the functional test, the entire the user flow from the UI perspective, and then we'll open the forum for questions and answers. So as I said, Polymer web development framework is mainly for UI intensive web apps. So you may want to use this for creating a lot of UI. If your application requires a lot of UI components, then you probably going to use this framework. The next is, it actually provides this framework provides polyfills, which is actually very specific to a DOM. So if you ask me what is polyfills, polyfills are nothing but a plugin, you can say, or a hack which provides a DOM manipulations and JavaScript manipulations for your DOM for a specific browser. Suppose if your browser doesn't support a specific event, right, or it doesn't provide a specific API, then this polyfills fits in, goes in there, and then provides you that, so that you can render these new components that you're going to create. So it's like providing the ability for the older browsers to work as the new browsers. So any new version will definitely have that ability, but then you actually want to go back and then provide it flexibility using polyfills. Again, as I said, so it's actually simplifies the way you create and manage your web components. The other benefit that you get with Polymer framework is you actually get a package of core elements that you can directly reuse in an application. So you don't have to develop them. You simply import them and start using those in your applications. Apart from just using the pre-built package of core elements, you can even customize those components and then accordingly use in your applications. So in case you have to do some customization in the existing core elements, you can go back and do the customization and use them. Okay, I'm going to show you how. What are these core elements? just to give you an idea how this looks like. So these are some components which comes with Polymer library when you download from the repo, right? So checkboxes, you see the effects and all of that. All of these comes for free with the package. So you have to import them and use it. So all of these effects that you see, right? This is already defined and developed. So you can use these, and probably for in cases where you have to define probably a new event or something you want to add upon to the existing core elements, you can do that by modifying the style sheet, and you can modify the component. So that's more of a customization that you want to do on the core elements. Falling back to these. Yeah, so these were the core elements, right? Let me show you another application which is paper calculator, right? So this application will use throughout our unit tests and the Selenium tests. We have taken as a sample Polymer application that we'll be using it. So you see all of these effects which comes up when you click on this. So if you look at this is the mix of only two components. One is your Polymer calculator and the other one is Polymer calculator key. Moving back to these slides. So now we'll talk about web components. Yeah. So web components are nothing but a specification in Polymer framework. How do you write your components? And that specification tells you kind of the semantic that you have to follow while creating those components. Helps you define custom tags. So get away with the existing boring HTML tags. You can provide your own custom tag, which is good. I would say a good feature, in terms of managing your components. Provides better management through components through data binding and reusability. As I said, these two are the main features which differentiates this specific framework from the existing framework. So, what is data binding and the reusability? Look into it. So, as the name suggests, right? So it actually binds the data within that component level. So, how it does is it actually combines the styling of it, the JavaScript part, and any logic that we develop is within the component scope. It doesn't let the style sheet effect leaking out of the context of a component. So you have a page, right? So you will have multiple web components created, but there is something which is not falling in the web components scope. So you won't allow that leakage to happen from the web component to the main source page, right? So it actually binds that entire stuff into web component scope. As I said, so it actually doesn't allow you to the effect to leak out of the other. So it actually eliminates the rest of the HTML source. Moving on to the usability. So data binding we talk about. Usability in sense as I said. So in spite of just using the existing core elements from the repo, right? You can even customize your elements and then host them over the web. And any other person around the corner, they can download those components and use them. So in that way, it's very reusable. So what are these specifications? Let's have a look one by one. As I said, custom tag, it provides the ability for the user to add a user-defined tags for your components. The other one is HTML templates. HTML templates are nothing but a markup that you want to put in your source. So suppose there's a counter that you pass it as a parameter, and you want some divs and spans. There's a block of div and span you want to repeat in your HTML source. So which is again based on logic. So you want 3, then the 3 list will be included in the HTML source, right? So a block of template, and you want to repeat that template multiple times. So that way you can actually reduce the markup in your HTML. Then comes your HTML import. So as I said, you create them and then you can import those components and use them in your applications. Shared DOM is another feature which Polyframe provides. So as I said, data binding. It's an underlying feature of your shared DOM. So what it does is, shared DOM is nothing but another chunk of DOM structure, which is not following the existing DOM structure from the page level. So if you try to get a hook of the element from page level, right? So you won't be able to get the element properly. So those are standalone DOM structures which are not bound to the page level HTML source. Yeah, let me show you how it looks like as I talked about HTML import, template, and shared DOM. Actually, I've saved this thing for you. So, site continues. Okay. Okay. So, as I said, the custom tag. You say polymer element, the name becomes a custom tag, and you provide the attributes there. I'm talking in the same context of as I said. So you provide an attribute which is like a counter over here. So you have to provide the value of a counter that goes into the template part of it. So here's a template, and this is whatever. So and this is the script that you write, and this is a template, and this file inside the template. So everything that is bound inside this polymer definition, this is like a class definition. So anything defined inside the web component will not leak outside, and it doesn't allow allow any other component to interact with it. So custom tag, shadow DOM, HTML template, which is this, as I said. So it takes the counter value and then provides. So this is the markup, right? Div ID and button on top of that. Yeah. So the other one is how do we use it? This is only the class definition that I showed you guys, right? So if you're working on the same HTML file, right? So you can simply write this statement, component name and the value of the attribute, and then start using this component. But in case you define a component in a separate HTML file, you want to import that component first and then want to use in the HTML file, right? So this is how you do it. So you have to use this statement to import that specific component in your HTML file, and then you can use it. I hope everyone is with me as far as the slides and the context that I was covering. Okay, so we have seen how a component is developed using Poly framework. Now we'll get into the unit testing part. How do we test those components? So, and Poly itself provides a way to unit test those components. That is WCT, Web Component Tester. So we'll see how do we do it. So my friend Shilpa will take you through for the unit testing part.
Thanks, Darpinder. You have seen how web components are developed. So, when coming up with Polymer, Google was evaluating several options to unit test a particular component. Say you have developed a new web component, or say you're using an existing web component, or you're using your elements. You definitely have to test them, test a web component thoroughly. So, after evaluating several options, Google has come up with its own test framework, that is Web Component Tester, a testing tool, to test the web components. So, Web Component Tester is basically a unit testing tool for Polymer, again by Google. So, it is configured out of the box with Mocha as a test framework and Chai as an assertion library. Mocha gives you flexibility to do a lot of things. So WCT package in itself comes with Mocha as a test framework, and since Mocha doesn't have an assertion library, they have included Chai as an assertion library so that you can write your assert with with the Chai assertion library. Since WCT is integrated with WebDriver, you can run your unit tests on multiple browsers at a time. And WCP helps you test a web component thoroughly, exhaustively. So what I'll do is I'll take you through a sample and show how it is done. Okay. Now, as Dharmendra was explaining, you say you have a particular web component. Okay. You saw the sample paper calculator application. That is, yeah. This is the sample paper calculator application. You might have several web components here in this web page. Right? Say you have this entire paper calculator, then you have individual keys, which is a web component, and these individual keys are giving you a ripple kind of effect when you are pressing on them. There are grids, say in one grid you have the numbers, in one grid you have the symbols, in one grid you have other functionalities. So you might want to test one particular component. In my example, what I have done is I have taken this individual keys and how do I assert, how do I write test and assert for individual keys. So here is my test. Say there is paper calculator key. This is the web component, a new paper calculator key. It has its own styling, and you have your div inside the template, and you have this script here.
Excuse me, Shilpa. Can you please increase the font if possible?
So, it's not visible?
Yes.
This is better? Okay. First thing, what we can do is, we can import that particular element into your test. So I have imported the paper calculator element into my test. I then have to instantiate it. So I am instantiating it here. And I can use it like any other element. I can do a query selector, select that, and write any test on it. Here I have taken a very simple test to test the ripple effect. That is to check if it's the ripple effect is a circle and I'm doing a recentering touch. So, and if I have to run my test, what I directly do is I'm running it on Firefox. If I don't mention any browser, I can run it on all the browsers at once, whatever the browsers are installed. So, one thing, this is the paper calculator test. Say this is for one component, and if I am writing multiple files, multiple HTML files or multiple .js files, then what I can do is I can call it all at once in this particular suite, and I can run this suite.
So basically, you're writing your unit test in HTML files. So gives you that flexibility as well.
Yes, WCP gives you a flexibility to write your tests as both HTML suites as well as JS suites. In fact, in our project, we even we write our tests in .coffee files, which at compile time converts into JavaScript. We basically use CoffeeScript because less noise. I mean, we can write it as we tell. Say like, I mean, it's as if we are saying something.
It's less verbose like a JavaScript, right? So you don't have to write so much code in JavaScript. So it eliminates that, and you compile that and again into JavaScript. But then the basic is it still requires JavaScript files. So when you write in Coffee, there's a compiler which converts into JavaScript files, and we refer those JavaScript files. So it's really a kind of an intermediate language that they're using.
Right. So, if you look at your terminal, you will be able to see the output here. Say, by the way, Mocha gives you a flexibility to run both on Node.js as well as browser. So if I want to see my tests on the browser, yeah, it even gives you that the test has passed, or if the test has, say, if I try to fail a particular test, it can even tell you where exactly it has failed. Say instead of circle, if it was square or something, and if I am running the test, it will even tell me where exactly it has failed. Yeah, here we are actually asserting that the ripple effect is equal to a circle in this case, and what the ripple type is. So it's pretty easy to write a unit test. Say if you have a new web component and if you want to test that web component, functional testing is a lot, it's time consuming, it takes a lot of effort to write, and you cannot test everything when you're doing functional testing. So if you write thorough unit testing for it, then functional testing will become easier. You can only write the integration points, etc. So this is how you test functional, do a unit test with web component tester. Want to move on with the functional testing?
Thanks, Jennifer. That was a nice explanation. Thanks. Moving on to the functional testing part. So we have seen how the unit tests are written and how do we write unit tests, right? So we have seen that it's only a component-based test that we write. So you can check for the classes, the events that you have included in your test, in your component are working fine or not. So, but in case from the UI perspective on the application, how each of these components are interacting with each other and how you create a user flow around that, right? So let's get into the function test because that talks about creating those user flows and not just the component level testing, right? So there's a catch, there's a challenge that you see with the shadow DOM. So shadow DOM is a culprit over here. So as I said, shadow DOM is a separate DOM structure which is not dependent on the parent DOM structure. So you cannot directly use your query selector all to access the element which are residing under the shadow DOM. So the first thing, very important, not all browsers support shadow DOM right now. So this is the reason why the polymer is not announced, formally by Google with like it's available throughout and it's in production. So this is again in a beta version which is going on. So they have provided support, full support for Chrome Canary version, but not for Firefox and Safari. So probably, but this is going to be the future because you have seen that how easier it makes to develop such applications. So I'll just show you how shadow DOM looks like, and then we'll see how do we write tests around those. So as I said, those are not exposed to outer DOM structure. And all your query selector, all these methods fails to identify the element. Then how do you get a hook of the element and make it work the way you want, right? So let me show you in application how this shadow DOM appears. So this is your calculator. To inspect. Visible to all, right? Everyone can have. Oh, it's not working, I'm not able to zoom it. Yeah, so the one that I've highlighted over here, right? So this one is your shadow DOM thing, right? Shadow root. So this is a paper calculator key which is defined, which is web component, right? So as I said, whatever you enclose within a web component definition, right? That becomes a shadow DOM structure. So this is the class, the web component starting over here and it's ending over here, right? And there's a the shadow DOM. This is actually holding the entire logic of a component, right? Now there's nothing which is accessible. So when you actually try to do a query selector all, like you want to look for ink container, you provide the class name, and in other scenarios, right, where you're not dealing with shadow DOM, then actually it works, and then you can iterate through it and get to the right element that you want. But in this case, it doesn't work. So I'll show you both the cases when it is working and why it is not working. So let me run through the same example where I'll add two numbers, and then I'll walk through for why it doesn't work in other browser, right? So I've used Eclipse for this test. I'll simply go ahead and run this test, and then I'll explain about it. So I actually used two tests, one for addition and the other one is subtraction. So this is the other one. So this is the Chrome, and I'm not running this on Firefox. I'll show the difference why it doesn't work on Firefox. As I said, polyfills are not available entirely for all the other browsers. So the effect will not be same. If you run the same script on a different browser, it won't work. So if I just change this to in the interest of time, I'm just running one test. So same script, no change, but the shadow DOM doesn't work in the concept doesn't work in Firefox. Yeah, so the script won't run. The reason being, if you do inspect over here, so you won't see that shadow DOM coming up over here. So it's right now available only in Chrome Canary and not in any other browser. So in near future we can expect this, like all of the latest browsers are supporting the Polymer components and then Polymer web framework. So you don't see the shadow over here, right? So that's the reason it's not supported right now, because every browser has own way to render these components. So you still see that it's working, right? But the testability goes for a toss, right? I'll go back to this script that what I've done. So what I'm doing is I'm providing this colon shadow. This is more like a trick, you can say, or it's more like a hack, you would say. So going forward, dealing with shadow DOM, you'll have to use this. So if you replace this, it doesn't identify the element in your DOM structure. So it actually bypasses all the other DOM structure, it only looks for shadow DOM. And anything which is inside the shadow, suppose there's a component and there's a child component attached to it, right? So how do we handle that? So in this case, I'm using, okay, this is just, I'm actually using click keys, another function, to click on the elements. So what I'm doing is I'm finding keys first through the shadow DOM, and then inside the key I'm looking for paper calculator. So there's a catch over there. Why I haven't used the shadow, shadow over there? The reason being, if you're already inside the DOM, shadow DOM, you don't have to provide the shadow DOM again, a parent-child structure, right? So if your child again resides into a shadow DOM, you probably want to put over there as a shadow, and it will work. Otherwise, it will give you an error. That's all pretty much from the functional testing and how do we write test cases from the UI perspective. That's all from our side. Thank you, everyone. We open for questions and answers now. Any questions? Yeah.
Assertions, which is testing actually the effect, ripple effect and all. So is that already provided in Chai, or is that the WCT framework has the addition?
ripple effect is defined in the styles. So you get that yellow lighting, right? The ripple effect is defined in the style sheets. So that's the style that we've created. So through unit test, what we did is we tried to read that class and asserted that it is that yellow only, nothing else in that sense. So if you develop your component in more complex way, right, you define some events to it, then you actually check for the focus out, focus in events. So it was a basic test to tell you how do you actually get through the component inside and then to take the events and the classes that you define inside it. Am I clear?
Yeah.
Yeah. So how do you test the routing of the pages? Like if the page moves from this page to another page, how do you actually test whether it's going to that page or not?
You might have to mock, unit test. You're testing, you're talking about unit testing or functional
Something
testing?
at a higher level, integration or at a higher level test. Page navigation.
Page navigation?
Click on this link.
So other pages will have something to assert on, right? So you log in, right? And then you go to the next page where you can see your name coming up. So you can look for that name as an assertion, right? You get the hook of the element and then read the text of it and then you assert it. Name as the next page.
It's like writing any other Selenium test. Say if you're testing navigation from one page to another page, you might have to wait for page load or check that page is loaded. So you can assert that way. But if you're talking about unit tests, you'll have to mock the rest of it. And again, WCT provides Syn and JS for mocking and stuffing. So Syn again comes with the WCT package.
So if you look at the test, the function that we written, you're not using any framework. It's just telling you how you actually get the hook of the element in case of shared object. And that's it's up to you how do you create a framework around it for your application.
Any further questions? Thank you, Dharmendra and Shilpa. As a token of appreciation and gratitude, we would like to gift you a small goodie. Again,
okay, we're trying to get started with setting up the machines. And I know there's one person over here, there are two over here who have your own laptops. What we're trying to see is we have 10 laptops, we can accommodate 20 people, we're going to have folks paired. If you absolutely want to have it on your laptop, we can try and install the software on your machine. If we can work with the laptops that we have here, we can maybe get a little faster. So what we'll do right now is, do we have everybody here?
I'm not sure. Do we want to wait for 2 minutes? And also, I guess we need to start off the workshop.
Oh, perfect. Let's do that. Okay, but in the meantime, we might need to give them the software to install.
Okay, yeah, we'll do that.
Hi, and welcome to DevOps 101. We actually have 5 facilitators here for this workshop. To give them a brief intro about them. To start with, Sridevi is a lead consultant at ThoughtWorks. She enjoys building, testing, learning, and sharing. Abu has a multi-personality. He's a dev, he's an analyst, he's a trainer, and a mentor. He likes to poke his nose into everything. And KK is a lead consultant with ThoughtWorks, and he has worked on a variety of technologies. Mukund is a consultant with ThoughtWorks. He gets so bored on weekends, and that is the reason why he's here right now. And Shraddha is a consultant with ThoughtWorks for almost 2.8 years and loves to code and learn new stuff. Over to you guys.
Thank you.
How many of you have thought of this radical idea out here? Just stop. I didn't say want to do it. Oh, we have 1. 2. Nobody is here who likes trekking. Trek freaks over here? No? Hands up. Show of hands, please. Wow. Okay, we have quite a few. Yeah, but for the rest of them, have you ever thought of doing this? No. Okay. Today we're going to do that, most probably. Let's see what it takes to do this. Yeah. What's the first thought that comes to your head if you actually want to do something as radical as this? Money. Wow. Yes, I didn't think about that either. But yes. What else? Passion. Yes. Physical strength. Leave. Very important. Yes. Anything else?
Planning.
What would your planning involve?
I cannot go the planning slots.
Yeah, you'll have people who will help you out, right? You're not going all by yourself. Like, yeah. I heard somebody say equipments as well. But yes, this is something that you can think of. You would want to have some kind of oxygen cylinders, you need to have some harness, all other things which you are probably not aware of, right? So yeah, these are very brief set of equipments that you might actually need to climb Mount Everest. So, okay, why am I actually talking about it? Why do you want to climb Mount Everest? Any thoughts around that? No thoughts at all. It's only crazy people who do this, right? Yeah, I mean, it's literally, so this person is one of them who actually said, we climb because it's just there. I mean, why would you ever climb a Mount Everest? What are you going to get out of it? Yeah. So, by the way, for today's session, whatever we're going to do has absolutely nothing to do with what we spoke right now. This is what we're going to do today, and we're going to get started with this. Cool? Okay. Let me first get started with this term. I know most of us have heard about it, but who wants to give it a shot? Like, I would like to make it more interactive. That's how I am. Please try to respond from the other side as well, so that we, try to make it more, I would say, fun. Sure. Okay, let's try to give it a shot. How many? Okay, we've heard about this term. Who wants to give it a shot? What do you think DevOps is?
Develop, test, and deploy.
Develop, test, and deploy. I see. Develop, test, and deploy.
Request hardware.
Sorry?
Requesting new hardware.
Requesting new hardware. Okay.
Virtual machines.
Virtual machines. Okay.
Provide infrastructure wherein you can easily host your code and then.
Infrastructure where you can host your code. Okay. Getting the right environments. Good point. Okay. So just to summarize it quickly, it's just about a practice. So we know when people face a certain set of problems in industry, a bunch of smart people apparently get together and they just try to bring out set of processes in place which are not necessarily something which you have to absolutely follow the way it is, but there are certain guidelines which we have to follow, which we usually follow, and we see a lot of benefit in them, right? So DevOps is a process that has been put in the recent past. I think it just started about 2008, where the development team and the operations team, that's usually operations or the infrastructure team. So these two teams are usually isolated in a typical setup. And what we try to do here is collaborate between these two teams and see how much of collaboration you can increase. So why do you think this collaboration is required? Do we need the collaboration at all? Like,
yeah.
Yes. Okay, I see a yes. So it's okay if it is wrong, but can you just think of any reasons why you need these collaborations?
To share the goals.
You share the
Vision and goals.
vision and goals.
And
Okay.
work towards it.
Sorry?
And work towards it.
And work towards it. Okay. What kind of vision? Sorry, I'm
Find the right solution for the problems.
find the right solutions for problems.
Yeah, it's like to understand each other's difficulties.
Okay.
Better utilization of available resources.
Better utilization of availability resources. That could be another interesting point as well. Any other shots?
I've completed the development. You need somebody to push that code to production. So
Awesome. So have you? Okay. Sorry. About the same thing. Okay, I have something related to what you just said now. Have you ever seen something like this?
yeah.
Yes. So we all say this, but why do we actually say this? So there is definitely, I'm sure you're not lying. You knew it was working on your machine. But when you actually deployed it to somewhere else, it's not working. Why? Where was the mistake?
My environment where I developed is not the same environment.
Exactly. It is not the same, but does it need not be the same? Or can it be the same? Why don't we have it to be the same? Have you ever thought about that?
Deployment has done, there's a fault in deployment.
There's a fault in deployment. That's one bit. But why is a fault in deployment? Why don't you deploy it similarly to what you do it on your development environments? You don't, right? And that's clearly why we see, and Can I have a show of hands who have never seen something like this? Wow, okay, I would be surprised if somebody showed, but yes, you would never have this, and you would definitely have a situation where, if you work in the IT industry for some time, you will definitely have discrepancies between the environments that you are currently working on and the environments that you actually deploy your work on, right? Okay, so a quick overview. So typically in a setup, right, you work in a development environment, you have something like I've just put in 3 just because I had no space, but you could have potentially more environments like a QA or a staging, pre-prod, and finally a production environment. But in all of these environments, this is one thing that is highly likely to happen, and for whatever reasons, like you can never match what production systems have in your local box, but you can simulate to be very close to that. And how you plan on doing that is from the day one. So let's say you have a production system which has like 27 web servers, but how are you going to say, okay, you want to have 27 web servers in your machine? You cannot, but you can have something very similar to what is set up in your production environment. Let's say, okay, even if you are talking about having a load balancer with just 1 web server, you still can do it on your developing box. But all that matters is how you actually set it up, right? So this is typical problem that we see in environment where developer has all these components, that's a web server, a database server, or be it a business server, on the same box. But we never realize why is it going to be a little different in something like a production server where you have a separate web server, separate business server, separate database server. What are the kind of problems you might get into this? How you mess up with IPs when you're doing something manually, or you've obviously experienced all of this when you're working on any of the projects. Okay, all of us. I'm hoping all of us have worked in the IT industry, right? So whenever we get started on a project, what is the first thing that we do? Any project, a new project, what is the first thing that we do? Machine setup, awesome. And how much time does it take typically for a machine setup? I'm just getting a random number over here.
1 day.
Sorry? 1 day? Okay, I heard 1 day over here. Any more answers that are slightly different to this? No? Just 1 day, wow. Okay, I have worked, I've not worked I would say, but I was in a consulting engagement where we went to help them out with their environments, and literally it took them 7 months to set up a development environment. 7 months. You can imagine how complicated it is, but it sounds ridiculous that you're actually putting all crap in your environment. Maybe there are a bunch of things which you don't really need, but at times it grows to a point that you cannot replicate what you have actually created. And imagine, okay, in day one, if you're taking 1 day to actually set up your dev environment, right? What happens if you actually want to set up like 37 such boxes? And you're actually billing the clients for every hour that you actually work. Right? You can do the math. Like 37 days, 8 hours a day. That's typically if you actually are following your wiki document or whatever properly, right? So that's a lot of time. And one other very important philosophy is you are doing it manually. And if you're doing it manually, you are probably doing it wrong. Just think about your approach again and see how you can automate whatever you're doing. Perfect. So now, what are we going to do today? We just spoke about these set of software that we could potentially install in an environment or in your developer box. Imagine if there was something which allows you to have all of this configured as code and stored in something like a Git repository. So I've just mentioned 8 or 10 softwares over here. You could have potentially 25 or 80 softwares or whatever configuration you want to do. What if I say you can configure all of that, store it in Git, and via some tool, which actually probably could be Puppet in our case, this is what we are going to use in the workshop. You can deploy it into 1 machine, 2 machines, 5 machines just by the click of a button. Right? This sounds amazing, and this is exactly what Puppet does, and this is what we're going to see in today's session. Right? So going on, our mission today will be to set up a developer environment which has these two components built into it. Yes, we could have had like multiple machines set up, but with having the time in mind, we will go ahead with just one machine and have this thing set up in an automated fashion. That's what we're going to do. So just before getting started with this, what we want to do is maybe talk about a few core concepts that we need to have some understanding of, and then we'll, without wasting time, quickly get started on a hands-on session. Right? Okay. Okay, I heard somebody mention virtual machines over here. Does anybody want to give it a shot? Like what a virtual machine is? It need not be right. Just whatever your understanding is, it's fine.
It's not actually a batchable. It's not a batchable machine.
Okay.
It's a machine over one over machine. Your one machine actually provides different machines.
Okay, it's not an isolated machine. It's something that you can have within other machines as well.
Yeah. So machines
provisioning within a machine. Okay. You have different operating systems running on different systems. Any other thoughts?
It provides simulation of other OS on another particular OS.
It allows simulation of running other OSs on another machine. Okay?
Without touch, we can use that is a virtual machine.
Sorry?
Without touching, you can use that machines.
Without touching?
Yeah. And this is virtually in cloud hosted.
Yeah.
You can access and you can use.
Okay, it's a virtual concept, I guess. Okay, sure.
It's an image.
It's an image. Okay.
It has a virtualization layer that abstracts the hardware and it allows all the operating systems to run.
Very close. So it has a virtualization layer which allows interacting with so I wouldn't say any of these is wrong either. Most of the answers are right or pretty much there. My way of just putting it across, it's just an operating system that, it's just a software that runs the operating system. You just give it enough hardware or whatever. You say, okay, you want this hard disk, this much hard disk, you want this much RAM, or you want this much CPU, you just allocate, and it is capable of running independently as a machine. So you can, it's obviously called virtual because it's running, it's not a physical existence, it's just kind of a logical abstraction, right? Cool. So now that we know a little bit about virtual machines, what I'm going to do is we need a few more core concepts that we need to talk about. I'm going to ask Shraddha to take over from here. We're going to quickly run through these core concepts and then we will maybe get started with the hands-on session. Right? Yes, no?
Yes.
Oh, awesome, thanks.
Thanks, Abu. Hello everyone. So Abu just talked about the virtual machines. So can anyone name any of the virtualization software that you have used or heard of? No? Okay. So yeah, we are talking about Vagrant, but it's actually not a virtualization software. It's a wrapper over the virtualization software that you just told, like the VMware or the AWS. So it's just a wrapper that it gives you an abstraction layer to actually interact with those virtualization softwares. So it's actually not exactly a virtualization software. So Vagrant gives us many other, it actually gives us the ease to interact with those software. It provides a common abstraction layer that you can use and interact with the different types of virtualization softwares. So Vagrant gives us the ease that in one command you can get your development environment up and running. So yeah, as the people said that there are some few common or very popular ones that we have showed here. So we'll just get into some very basic Vagrant commands that we'll be using through the workshop. So the first one is the Vagrant box add. So box in Vagrant terms is just a base image. To create your virtual machine, you need a base image, like you want to create a CentOS box or a Windows box. So those images are called box in Vagrant terms. So this is a command which creates an alias for your box image. So you download one image and give it a name. So it just you use that name for simplicity in your configuration. So it gives you just an alias for your virtual box, for your image. The next, so when you use this command and you do a vagrant box, add box name, and the address could be your local path or the remote URL from the internet, from where you're downloading the box. So when you run this command, you'll get a base box. And the next command that we'll look into is the vagrant init. So as the name suggests, init, it initializes the vagrant box. So what this command does is it creates a vagrant file where you can have all your configurations you need to apply on that virtual machine that you are just about to create. So till this point, we don't actually have a virtual machine or a VM. So the next command that we have is vagrant up. So this is a command that actually creates your VM and provisions it and configures it according to what you have mentioned in your vagrant file. So there are other commands like vagrant halt. So vagrant halt is a command which actually gracefully shuts down your VM, like you shut down your machine. So and there's one more command which is vagrant destroy. So it actually destroys each and every trace of your VM from your machine. So there are other important commands like vagrant SSH. Once you do a vagrant up, you have your VM. If you want to go and SSH into your VM, you use this command from your current directory and you are in that VM. And there is vagrant provision. Once you have your VM up and running, you can use this command and this will actually provision your VM according to the provisioning script that you have provided in the vagrant file. So here are all the commands that we actually talked about. And Sridevi will be actually doing the hands-on for the vagrant.
Hi everyone. We'll do a quick hands-on now for vagrant alone. And then depending on whether we want a break after that, we'll actually see whether we want to take configuration management after that. So shall we get started with vagrant very quick hands-on? Can you all try vagrant box list? I'll use my laptop if it is required. That is going to be very quick, so just. So if you have any questions, you can reach out to the volunteers. You know all the volunteers, right? Yeah. So we'll do a quick vagrant basics now. Can you all access, can you all type this vagrant command and see if it's working for you? At any point, anybody is not seeing the output that you are seeing similar, to the output that you are seeing here? Raise your hand, and then we'll see what is wrong. Okay. So the machines that you are using as workshop machines, right? So they are all installed with vagrant software. If you want to do it, at home you can install it, and it's a simple installer that gives you this command line interface. And those who are using their own machines, do you have vagrant installed? Okay. Now, as Shraddha has mentioned, box is what vagrant calls a base image. So if you have used virtualization software, there is something called as a base image or a template that could be used for spawning new instances with the same configuration as the template. So box is a vagrant jargon for it, and vagrant wraps an underlying image. Let us say VMware or VirtualBox has a particular format. Vagrant does some packaging on top of it and then gives you a .box file. That is, there are many .box files available for different configurations on internet, and we have used one of those. You can look up the base boxes for vagrant on this site. This is typically the site that we use for different base boxes. And we have taken one of these images as our base image. Okay? And once we download that image, we add it to our vagrant environment. there is a vagrant box add command, and you have to provide the path of the base box. After doing that, the base box is now available for you to use to create new instances from it. So can we all do a vagrant box list and see if you have at least one base box there? Okay, you must be seeing, which box are you seeing there? CentOS 64, right? Okay, that is what we have configured. So now what we are going to see is how to create a new instance of it. Before that, I want you to open VirtualBox and see. By the way, I think I forgot to mention, we are using Vagrant over VirtualBox now. So as Abu and Shraddha has told you, Vagrant is an abstraction layer over different virtualization softwares, right? It could be VMware, AWS, VMLogix, or VirtualBox. VirtualBox is a free virtualization software, and we are using that. So you have VirtualBox also installed on the machines. So can you open up VirtualBox GUI? You must be seeing no images, no VMs, or one VM or two VMs if at all. Okay. So what I want to show you is that when you create a new Vagrant instance, it is actually created in VirtualBox. Okay. So keep it like that and go back to the terminal. Can you create a new directory with any name? Say my new VM. So I just did mkdir my new VM. Okay. Now cd into the my new VM. cd my new VM. Here we are going to do a vagrant init. Vagrant init initializes any directory as a vagrant instance, and what it actually does is it creates a vagrant file. Vagrant file is a very important file for managing Vagrant. It has all the VM configuration information, like the RAM size, the hard drive that it uses, in addition to some provisioning information. We'll talk about provisioning information later, but we'll look at the other configuration. So do a Vagrant init, and as an option here, you can pass the base image that we have just seen, CentOS 64. So this is going to create a VM based off of the CentOS 64 image that we have. You should see some output like this, that a Vagrant file has been placed in this directory. Okay, so if you do an ls, you'll actually see a Vagrant file. I'm just opening up the Vagrant file here. If you are not yet done, raise your hand, I will go slow. If you are not done, raise your hand, that will go slow. Roll good. So are we all looking at the Vagrant file? Okay. Vagrant file has some information,
Yes, sir.
Okay. Vagrant file has pretty much all the information that Vagrant requires to create this VM. Firstly, it has the name of the base box, CentOS 64. So when you come here next time and then do a Vagrant up, it knows which which base image to use as its template. So because we have done a vagrant init center 64, we are actually seeing the center 64 here. And then it has networking information. How this VM should network, whether it is to be hosted in a private network which is local to your host machine, or whether it should be given a public network IP. If so, what is that IP? And then it has provider information. This is an important piece of information. It details which provider is being used. You can see that VirtualBox is actually commented out. The reason being it is the default provider. If it was any other provider, then that information would be actually mentioned here. And then you can see some provisioning blocks. We are going to talk about provisioning blocks. I'm going to leave it out right now. Okay? So this is a vagrant file that is created when we did a vagrant init. Now I want to do vagrant up. Can anybody tell me what this would do? This command would do? Okay, when we did vagrant init, did it actually create a machine for us? Let us see. Can you all look up in VirtualBox? Can you see if there was a new machine created? No, right? Okay. Now let us do a vagrant up. Vagrant up, as you can see, is using the vagrant file, and it has created the VM, and it has also powered it on. So now can you see VirtualBox and see a new VM added there? So whatever commands we will do through vagrant will actually be applied on this VirtualBox VM. So vagrant in turn uses VirtualBox's command line itself. It's just a wrapper on VirtualBox so that it creates a common abstraction for different virtualization platforms. Okay? Shall I go ahead or? Okay. Now we see that the VM is running. To halt the machine, that is to power off the machine, we use the command vagrant halt. Do a vagrant halt. Okay. Now it's talking about graceful shutdown of the VM, and you can see that the VirtualBox is actually shows it as powered off. Okay.
So this is just for viewing here, right? This is just for viewing. Yeah. So you don't even need this. You don't need this if you know by default and you know how to use it. Right? You don't really need this. And sometimes this VirtualBox is on your machine, but sometimes you can use a provider which is not on your machine, which can be on the cloud. So you can use Amazon website, or you can use Rackspace. So it kind of wraps up all of that. Just
yeah, sure.
Because it is used for but we can change this to say that I don't know if it's also possible. So this one has nothing to do with the function. We are just using it to see what is happening really, right? So that's the only reason that we are using it. Even now, if you say vagrant up there, so there is only one vagrant up there, so it's still up there. We don't really need to take a look at that anymore.
So if I jump and there are
they get access to you know they do like I mean you other ways of doing it. So we have like forget about one thing. Now you know this is the UI
You're all good?
By the way, I had one fundamental question. Why are we using vagrant over here?
Yeah.
Simulates the.
Just because it is there.
Okay, she's making it fun of me. Yeah, why are we using vagrant over here? Do we really need it?
Take a guess about they're getting scared of you.
Sorry. I don't know if I'm that
So,
scared, but
yeah, take a guess.
They're trying to simulate the production setup.
Yes, that's an eventual plan.
Oh.
Okay, like Shraddha mentioned, it's an umbrella. Vagrant allows you to just spin out environments. So all you need to tell Vagrant is what configuration you're using, what virtualization software you're using. You could use VMware, you could use VirtualBox that we're doing right now, you could use Parallel, there are like a bunch of other softwares. We could also maybe try and see how we can use Amazon's AMIs as well. Right? The idea is it gives you a clear abstraction of this thing. Now this vagrant file, vagrant init that you have created, all you have to change is your provider and all your setup that you're doing for creating these VMs, right, will be put into that VM. So for our session right now, we're just using it because of the ease in which you can create a virtual box. Imagine if you had to do that using the it will be a little bit more complicated. Here it's just like using VirtualBox. So she showed you the place where you download the VirtualBox and you have to go ahead and expand. There's a way you can go ahead and put it into the VirtualBox itself. But we are not really caring about how we use VirtualBox over here. We're just trying to abstract ourselves with whatever happens with creating of virtual machines. And we're using Vagrant for that.
Right.
What are the alternatives of training someone?
There is no alternative to vagrant as of today.
You can maybe create one.
Yeah.
It will be a good
So
complicated.
if you want to run any script, you want to make it up, you want to run.
Absolutely. That is what is called as provisioning, and we'll see that in detail. Let me run through the rest of the things. I'm making it a little quicker so that we can actually get into the workshop, hands-on. This is like prerequisites, okay? So now that you have tried vagrant up, vagrant halt, can we make it up again? Do a vagrant up again, which is supposed to bring up the machine, right? If you do a vagrant up now after halt, it is actually supposed to bring up the machine. So do you have the machine running again? Okay. Now, if you are seeing the machine running, can we log into the machine using vagrant SSH? Can we do a vagrant SSH into it? Can you all guys and ladies, can you all people confirm me that you are able to see you are into the virtual machine itself? Okay. Now, how do you know that this is actually virtual machine and the terminal isn't tricking you in some way? How do you make sure that is so? Yeah, do a host name. It says vagrant CentOS 64.vagrantup.com. Does it say that? Okay. So host name, I think this is actually down maybe. I did a host name inside of the vagrant VM. Okay, good. So once you are able to log into the machine, you can actually do any kind of work on it, right? So we'll be using it. The next command is destroy. So you want to come out of the machine, and now we have seen how to bring up the machine, how to stop the machine, just power it off. But if you have a lot of VMs on your host machine, right, you want to destroy them and then later create it. So you have a command called vagrant destroy, which destroys the machine. So this will actually make the VM disappear. So try vagrant destroy and see whether it is removing the VM from VirtualBox.
You cannot do from there because it is on your host machine. So that's a virtual machine.
Did we run vagrant destroy? And the VirtualBox VM is actually removed, right? Cool. So that's the end of the Vagrant 101 or Vagrant basics. We'll be using those. Yeah, some people are unclear.
Is everybody able to run the commands? If you're not, please let us know because we're here to help you.
Yeah.
We want to make sure everybody goes, they can run it.
How is this different from halting the
machine? No.
From hardening the machine.
Halting the machine.
Vagrant destroy. Halting was powering it off, whereas vagrant destroy was actually deleting the machine from VirtualBox.
So now you'll have to do an init if you want to.
You have to do a vagrant task. So that's a very good question. So the directory has all the configuration information that is enough to recreate the machine. So you can check this into GitHub and then later on reuse the same base.
If on this machine you're accessing the internet, it goes through the host. So and that's the reason why you have these different local configurations here.
For those that are done with the commands, I have a question. For those that are done, you might. So we have destroyed the machine. The question that came up is, how do we recreate it? Anybody wants to take a guess at how can we recreate the machine with the same configuration? Vagrant up. If you do a vagrant up again, it recreates the machine. So vagrant up does two things. One thing, if the machine isn't there, it recreates it. If it's already there but halted, it brings it up. Okay, so with that, actually I am done. I know I'm rushing because in the interest of time. So what shall we do now? Shall we take a quick break now and then come back for configuration management? Continue. Tea break? Yes. No, I want it.
Okay, let's continue. So Shraddha spoke about the basic vagrant commands, right? And she spoke about provisioning. So what do you guys think we do when we actually say vagrant provision? What does provisioning include? Any guesses? Sorry? Basically when we talk about provisioning a VM, we are talking about installing our required softwares on the VM, the deployment of our app to the VM, and things like that. So how do we actually provision a VM? There are two ways to do that. It's a scripted approach, or we could use a configuration automation framework. So what do you think are the advantages of using a configuration automation framework for provisioning your environment over a scripted approach of doing that? Any guesses?
Specify different images.
Yes, so multiple platforms. Yes.
You can reuse it.
Yes, reusability. So I'm just going to go through the points that I have here. So the solution that you create using a configuration framework is an idempotent solution. What I mean by an idempotent solution is you apply a function to a state of the machine and your machine reaches the desired state. no matter how many times you apply the function again to the machine which is in the desired state, it's not going to affect it. So say we have to install Java on a machine, right? And the configuration framework is intelligent enough that when you say that check if Java is installed in the machine, it actually checks that, and only if Java is not on the machine, it's going to go ahead with the installation. So we have an idempotent solution. Cross-platform, like one of you mentioned. So the same code which you've written in the configuration framework can be reused for creating instances on a CentOS machine or an Ubuntu machine or any other flavor that you use. The code written for the configuration framework, we'll be using Puppet for our workshop, is testable and maintainable. The code is structured in an object-oriented way, which makes it really easy to reuse code. So I'm going to go through the basics of Puppet commands. The most basic thing that we have is a Puppet resource. So resources are like the most basic commands to the operating system. They have 4 attributes. So you have a type, can be package, or can be exec, can be file, or service. So these are the different basic resources. It's not an exhaustive list. There are a number of resources which you can check from the Puppet documentation. These are just a few that we will need for our workshop. A package resource is used to say download a software from the internet. An exec is used to execute a command that you have mentioned. File resource is used to create a file or manipulate the contents of a file. And the service resource itself is used to say start or stop a service. So this is the syntax. You specify the type of the resource, a unique name, which is the identifier, and attribute value pairs, which describe the state, like ensure present. So we do not actually talk about what the resource has to do, but we always talk about the destination or the state in which we want our machine to be. So it's going to check like, okay, Java needs to be present. We don't say install Java. This kind of helps us to ensure that our code is idempotent. Classes. Why do you think we need classes? We spoke about resources, right? Basic commands to the operating system. So we use classes in order to achieve a higher goal. Say, I have to install Java. What are the steps? What would you actually do to install Java on any machine? Okay, say any software for that example, right? What do you do to install a software on a machine? Correct. You download the software and then you go ahead and install it. So those can be 2 different resources, and that can be clubbed together into a meaningful class. So you download the JDK and you install the JDK. These 2 resources are grouped in my class called Java. So what you see here is a custom resource type I have used, common file download. I'm going to talk about that soon. So that is going to download my JDK, and the second package is going to ensure that Java is installed, and the provider that I'm using is RPM. So I mentioned the providers separately because we want to use the Red Hat package management for the workshop. So let's look at a custom resource type itself. You define a custom resource type by using the keyword define, followed by the name of the resource. I've named it common file download. And you pass in the parameters that it needs. So the source, destination, file name, and options in this case. And then whatever needs to be executed as a part of the resource, I've mentioned. So I'm going to get a source and a destination, and I'm going to execute the command that will actually do a wget, which was the basic resource we saw on the first slide. And it will download the JDK from the source that is being passed in. So we've spoken about resources and classes, but in Puppet what happens is you have 2 steps to actually using a class. You declare a class, is what we just did. You specify the state in which you want your machine to be, and then you define the class or you include it. You do that in a thing called manifest. So manifest is the place where you actually include all your classes. So I'm going to say include Java, and only then is the code that I've mentioned in the class be executed. So what Puppet does is, it takes the various manifests that we have created and compiles a catalog out of it. So this catalog is going to take care of all our dependencies. I'm going to need to install Tomcat server, but there's a prerequisite that Java needs to be installed. So the catalog is going to take care of these dependencies that we have mentioned in our class and compile executable for Puppet to run. When the catalog is executed, magically we're going to have an environment set up with all the softwares that we've mentioned in our manifest files. That's about it. So now we'll go into the workshop itself, and I think Sridevi will take over from here.
Let me try without using this. Can you all hear me? Go without it. So what we're going to do now is we are going to create a VM using Vagrant for hosting the app that we were talking about. And I'm going to walk you through the app itself. And after that, we'll do a quick Puppet basics first to get simple manifests running. And then we'll get into actual work. Sounds good? Okay. So, as I told you, to-do server is going to be the Vagrant VM on your host machines. It has, it is supposed to host a to-do backend and a to-do frontend. Okay. To-do backend is a Java application, which means you require Java. You require to download and install JDK, and then it can be deployed. It's a WAR file. It can be deployed on Tomcat. And the to-do frontend is a very simple HTML app which is going to consume the web services that to-do backend is going to provide. So to-do backend simply gives RESTful web services to create to-do lists. Okay. To go about it, we'll actually firstly brainstorm on how we want to break down the problem into smaller logical chunks, and then we'll see how Puppet can help us do it. Okay, so this is what you need to do. Now, can you tell me how we should go about it? Where do you start? Install the required software. So you start off with installing JDK because Tomcat also requires JDK, right? So to install JDK, what could be the steps? You download the package. We are using CentOS, so you download the corresponding RPM from internet, and then you install it using RPM manager, right? So do you want to do that manually first, or do you want to use Puppet itself to do that? Pardon? So how do you want to go about it? Do you want to try it out, try doing whatever you want to do using Puppet manually first? Or if you are already comfortable, we can actually skip that part and go about using Puppet directly. Use Puppet directly? Okay. Does that sound good to everybody? Okay. So, so what we'll do first in that case is we'll start off with writing a simple Puppet manifest. So Mukund has talked about some core Puppet concepts. The most basic building block is a resource. A set of these resources are actually combined in a class to do something more meaningful, to achieve a higher objective. And then a manifest has calls of these classes to kind of invoke them, to run them. This is what we understood, right? If you want to go about installing Java, what would be the resources that you would want to have? I know I'm just talking about it without you actually looking at anything in Puppet. How many of us have done Puppet before, by the way? Okay, so that is good. So what can you think of being the most basic units here? But we are talking about, we want to do installing Java right away. We talked about downloading file and then using a package manager, installing it using RPM. And Mukund has given you some basic built-in resources. He has talked about 4 of them. Actually, there are many of them. There are some 40 of them which are built in and provided by Puppet. These are the ones we use for the workshop. So we talked about an exec resource, a file resource, a package, and service. Service I'm not sure whether we use it, but so downloading JDK. How do you do it when you do it from a CentOS machine or from any Unix machine? How do you download files? wget, right? And you need wget to be installed even before you use it. So, do you know if the CentOS machine that you have already comes with a wget? We don't know, right? So you want to first of all see whether wget is already installed. If it is not installed, you want to actually start off with installing wget itself. And then we are doing some downloads, so we need some directory to hold them. So we need some prerequisites to be set even before we start off doing this. So shall we get started and doing it? Instead of you actually trying this piece out yourself, what I thought would be better is to have a branch in the DevOps environment repo that you can actually look at and that you can take as a reference when you are actually building other things. Does that sound like a plan? Okay. So the repo that we are going to use, I'm writing down the URL here. I hope it is visible to all. I don't know how better I could have done it. Do you want me to connect to the... yeah, I'll still write it here. I'm also going to project it. Okay, so the others who you're pairing with, do they know Git? You can swap maybe if...
Are you guys comfortable with it, or we can have yours?
We'll just use some basic Git commands.
So what we're going to do is check out this project.
All of you who are using workshop machines are seeing a DevOps workshop folder, right? So inside that, can you do a git clone of this URL? If anybody is not done, can you raise your hands? Otherwise, I'll assume that you are done. You all check out stage 0 bootstrap once you are in. Once you are in DevOps 101, right? Inside DevOps 101,
when you do ritual, you need to CD into the repository.
It's part of you.
Does that work? This is the font. I did that. I'm not doing that. Are we all good? I'm not seeing any raised hands. I'm proceeding. Okay. So we are going to do a quick walkthrough of the code that is there in this.
On the branch.
All of you must be having Sublime. The workshop machines will have. The others you have some editor, right? So can you open up DevOps 101 directory in any IDE?
You can do Sublime dot on there. It works the same way.
Okay.
Can't you directly do a sublime job?
I don't know.
There is something listed from there.
Okay.
You want us to copy the
No,
file?
don't worry about it.
Which one? What I have done? No, do not do that.
So you just imported that folder here, right?
Okay.
Now she's
So I'm moving on. I guess you're all looking at DevOps 101 folder, right? So this folder actually has a Puppet directory and a to-do server directory. To-do server directory holds the vagrant information. It does not have anything else excepting vagrant information and provisioning information. We'll look at it later. Okay? So this is a little different because I copied something. Puppet has the infrastructure code. So whenever we go to a particular branch, copy the Puppet code into the server directory. But we'll do that in the next stages. For now, let us look at what is there in the code itself. Okay. So DevOps 101, you must have a Puppet directory, and there is a site.pp here. And in modules, you will be seeing a Bootstrap module, which again has a.
Can you maybe increase the font?
I tried increasing. This is not.
If it's okay with others to.
But still, I do not know how to increase the font of this side, unless you know. Are you okay? Cool. So here we are actually seeing some things that are new to us, right? So we are seeing modules and manifests and so on. So I want to walk through the basic Puppet directory structure itself. Puppet will typically have a manifest and modules directories. So manifests will have calls to classes, as we have discussed earlier, and modules are like Java packages. Think of them like Java packages, which could be a collection of classes which are logically organized. So, okay, a module holds multiple classes. It's a directory structure, and it has some conventions. I'm going to tell you what those conventions are. So to write a new module, you have to have it in the module path, which is typically Puppet modules. Let me know if I'm confusing you. Okay. Where should I write it? What can I get rid of? Puppet structure. The root directory is Puppet. In that you have a manifest folder, which has some important manifests, and then you have a modules folder, which contains Puppet modules. So what can you liken, what can you draw a parallel to Puppet modules? They are like libraries maybe. So the code itself will be in these modules, whereas the manifest will actually have classes to the calls to that code. Okay. So in our example, we have one Bootstrap module whose purpose is to do some bootstrapping required for the server. So as we have discussed earlier, if you want to download something, we want wget to be installed on the machine. So we better have that in our Bootstrap, and make sure that that runs ahead of all other tasks. So we have created a Bootstrap module. There is a specific convention that is required for these modules. That is, it needs to have a manifest folder inside it again. Okay. And inside of manifest there needs to be an init.pp. So it may be a lot of things to remember, but just try to do that. So Bootstrap, every module needs to have a manifest folder which has an init.pp file. That is like mandatory, or Puppet will actually throw an error.
.pp is the extension used by Puppet for the manifest files. Yes.
Right. So inside of this init.pp, you can't have anything that you want to have. You need to have class definition which maps to the module name. So init.pp needs to have a class Bootstrap inside it. And this is a class declaration. As Mukund mentioned, this is a class declaration. There will be a class definition elsewhere which executes this code. and class definition happens using either include or an explicit call to it. Okay, so class bootstrap is there. Now what do we want to do that inside of that? We want to have the resources that are actually doing the task for us. So we want to have a package resource which installs wget, and then a file resource to install some directories that we require. That's exactly what we are doing. So if you look at the bootstrap modules, init.pp, it has class bootstrap, and then there are some variables defined there. One is for installer directory and the other is for downloads directory. And then you are installing package, wget package, and installing creating installer directory and also downloads directory, ensuring that it's a directory. Do you understand why you have manifest and modules, two directories?
So the bootstrap are always improved faster. The bootstrap is always improved faster.
We have to create that dependency. We'll do that. In the next stages, we'll actually do that. Right now, it is just bootstrap, so it will execute all the resources that are there in bootstrap. But we'll talk about dependency management in a while.
One question here. If I want to, like other than Bootstrap, if I want to install a few other resources, do I need to create another folder which is similar to Bootstrap? Or just if I add another init file?
You want to have another? What is the purpose of that?
Whatever software I need to install, can I get it done in the Bootstrap?
Yes, right. You can add it here. So it depends on how you want to organize your resources. Okay. So are we clear so far? Now we need to run this, right? But I haven't talked about something called as site.pp in manifest. So again, Puppet requires, I think Puppet is very strict with, for its conventions. It requires a manifest to exist in manifest folder for it to start off its execution. So even these modules are having manifests. For example, init.pp here is also a manifest file, but it cannot actually run this one directly. It requires a file to exist in the manifest directory, which is defining classes as opposed to declaring classes. Okay, the usage class definition might be slightly different from how we are used to in Java or elsewhere, where we say class definition actually means you are defining the class, and then invocation means you are invoke it or calling it, right? Here definition means actually calling the class, and declaring means defining the class code. Okay, so now we'll go ahead and run this. We'll actually see it work. As you can see here, the site.pp that I'm going to start off Puppet execution, it is including Bootstrap, which means I'm making a call to the Bootstrap, Bootstrap's code itself. When I do this, when I execute this site.pp, what happens? It executes the Bootstrap resources. So do we want to go ahead and see? Okay. Now, I hope you are all in DevOps 101 folder. Yes. There is one thing that we need to do whenever we are checking out branches and so on. It's a convention that I followed, that the Puppet code is there in DevOps 101 directly, and to-do server does not have any Puppet code. Okay? So can you copy the Puppet directory into to-do server itself, so that the Puppet code is available to the to-do server machine? And
so I think in the interest of time, what we could probably try and do now is you can anyway go through the code and see how things hook on together. we can maybe get started with running them and see how it works.
Yeah, right. That's what I'm going to do now. But regarding the time, right? Actually, I think we have more time than what we usually have. It's now we can take up to 5 o'clock. I'm not sure.
No, it's not.
Well, the thing is that the other thing is still running because we started earlier and we have the closing of the that's
It's still running and see all the software are installed. Anytime you want to know what's happening in it, the code is already there. You can go and see how things will come together. And what Sridevi is trying to do is exactly the same thing. Explain the code and tell you how manifests and objects are organized and how the whole thing, where the starting point. So we will maybe get started and we'll do the other bit where we try to apply Puppet with the VM and.
How much time do I have? Half an hour tops?
Kiki just said, I thought it was 15 or 20 minutes, but 4:30 is what they want to get started off with the closure.
Yes, 4:30.
They
Can
want-
I take up to 4:30? 4:20, 25. That looks like bargaining, right? Okay. What do I do now? Okay, I think you got the concept and you got the directory structure, right? I would like to go to installing Java itself. Is it okay? Okay. So can we quickly check out? Can we first of all look at all the branches that are there? Git branch -a. So you can see that there are 5 branches starting with 0. The second branch actually creates a very handy papply executable that executes the Puppet code. Okay? I'm skipping these two. These are progressive stages. That means whatever is there in stage 0 is available in stage 1 and so on. So the last stage is stage 4 where we are deploying the app. If you get it to work, you actually see the app deployed and you can actually create to-do lists there. Okay? So we can start up with stage 2 Java itself where we are seeing the machine provision with Java first and then Tomcat next and then copy var and so on. All the softwares that the code is using are hosted on a file share server. So if you see, if you do a cd ... and look at your DevOps workshop folder, there is a file share VM that is there, which is started, which is actually hosting all the softwares.
So if you actually hit the URL, okay, the reason why we are doing this is we didn't want the network thing to come into our session and because of slow internet or maybe the resource not being available at one point of time. We didn't want to delay, but typically we share all the resources in some file location, and this that you see over here should be available on each of these individual laptops. And we've just hosted them over here right now, all the resources that we need.
Yeah. So this you can see that I have a Tomcat, jar file, JDK RPM, and then in apps there is a to-do war and a to-do list app. So are all of you able to hit this URL 192.168.33.22 8,000? And you're able to see the files, right? Okay.
Yes,
Do you have file share? Yeah. Okay, shall we move on? Raise hands if you are stopped. So, 3322. Start the server if it is not already started. Okay, you have to start the vagrant. You have to do a vagrant top inside of file share. It's a script that is running inside of the VM. Who doesn't have it up and running? You don't have it. Is it running now? It's running now? Anybody else? Without this, we don't get anything to work actually. So it's like internet for us. It's like Google for us.
Yes. Yes. So if you read this, we get function. This is a photo of other things. Just start.
So function is a VM that we have created and configured using Vagrant. This is just a host files that will be loaded. Okay, it says it's already loaded. So you should be able to run this
Are we all on the same page? Okay, we are waiting for some people to finish. If you have any questions in the meantime, we can take it.
So this image is file server image or something.
Yeah.
Before we were running, we just copied the work and this is like file server.
It is just, the name is file server. It is running based off of the same base box, CentOS Explore. All that it has is, it's a directory which has all the softwares.
So when you time it is figured out that machines are running and it's available to be.
Yes. If you look at bootstrap.sh in it, it runs a simple script there. Makes it a Python HTTP server which makes those softwares available
on the internet.
There's one.
But now we are downloading from this server, right? Because like when you do this, right, when you browse it,
Do we have file sharing? Okay, we are now checking out stage 1 Java, stage 2 Java. Can we all check out Java? This is something that we can actually see running. Have you all checked out Java? We are all good? Simply run git checkout stage 2 Java. As I told you before, we have to. Okay.
And just call response another VM.
Now just do a Vagrant box app.
No, the box is the only thing I wrote. I changed the Vagrant file. So if you point to that base box, and now
if we all have file server running, we should be able to go ahead.
It's worth it, right? So now, after the setup, you will be able to access the file.
Okay. So once we checked out Java, stage 2 Java, right? Can you go into to-do server? Go into to-do server and then open up the Vagrant file and go down or search for Puppet. Just search for Puppet /Puppet if you are using PI. Okay. So here you can see that we are actually using provisioning that we have not seen so far. So Vagrant file. So going to to-do server, there is a to-do server, right? And you can see Vagrant file which have this piece of information. So Mukund spoke about provisioning, right? Vagrant's provisioning. Vagrant can actually handle multiple provisioners. Puppet is one of them. You could also have a shell provisioner. So we are also using shell, by the way. We use it just to set the host name. The way provisioning works is that it takes paths relative to the vagrant directory. So I have a shell provisioner here, and I'm saying the path is bootstrap.sh, which means it will run bootstrap.sh while it is doing vagrant top. Similarly, when it is doing vagrant top, it will run the Puppet provisioning. And the manifest file information is here, puppet/manifest/site pp, and then the modules are going to be picked up from Puppet modules. We have seen what site.pp is. We have not exactly seen it, but we'll look at it now and then we'll figure it out. Okay. So I wanted to show this to you because now when we do vagrant up, Java is going to get installed, and this is the reason why it's going to get installed. Before that, as you can see that we are using Puppet relative directory, right? It expects Puppet to be inside of the root directory. So in your to-do server, there has to be a Puppet directory. I haven't copied it because infrastructure code is not supposed to be inside of a VM. It's supposed to be separate. So copy the Puppet directory that is in the parent directory into this folder.
Can you just show the command?
Yeah, cp, yeah. So once you are into to-do server, run this command.
So
cp -r.
like we said, typically if you want to manage both these things, Puppet should have been a separate repository, and vagrant related stuff should have been a separate repository. And if you know Git well, we could ideally have a sub-module over there where you maintain your Git related stuff separately and vagrant related stuff separately. But for this session, we just wanted to not get into those details, and we just asked you to do this manually.
So manually copy the Puppet directory from the parent directory into to-do server. I hope this one does it. Yeah. So now you have a Puppet folder here. What should we do now? Vagrant up. Do a vagrant up. Am I missing anything? Do a vagrant up and see what happens. Is something happening when you're doing vagrant up? Are you lost? No.
Provision using Puppet, use Puppet manifest. So this Puppet, right, is from this directory. There are two server, right? So you Puppet manifest, you include the manifest file and the modules. So that's what you do. So here you do this vagrant up, right? Once you do that, you can use a vagrant and check whether Java is installed or not. Because in this stage, we just try to install Java. Okay. So if you look at this branch, like later on, when you go to this
So are you saying Puppet running? Is any of you saying the blue colored Puppet run? It hasn't yet come from you so far. Once you are done, so did it say finished catalog? Not yet, right? So it's doing some hard work there.
Using Puppet to provision the VM. So in this stage, we just installing Java here.
Is it working for you? Provisioning finish. So those who have seen the provision finish, can you log into the box and check if Java is installed? RPM minus E, right? Minus Q. RPM minus Q JDK. You can just write minus Q and a query.
Whatever is required latest is all set up. But it will not install again because it's already because of the identity. So yeah, basically that's what it
The maintenance RPM minus V JDK. I believe that is the RPM minus Q JDK. Minus Q space JDK. It says not installed. It says installed. You did something wrong. RPM minus Q space JDK.
You're on a local machine. Do a vagrant install.
Do go into the machine.
I just know.
So take it because some people got it, and actually we supposed to end in another 5 minutes. I want to run the last stage. So the code is checked in GitHub. It's a public repository. You can always take a look at it, and the apps that we are using are also open source apps. So they are to-do backend app and a to-do frontend app actually. I can share the links of that. I'll post them, on my blog or how do we reach out? I don't know. We'll figure that out. But so everything you can try it on your machines after you get through. So there is some logistics reason why we are having to shut it down like this. So shall we move on to the last stage? We'll do one thing, KK, for Sai Krishna, right? Do a vagrant destroy, we'll go to the last stage. If it doesn't work, then we'll sit actually. So let us check out the last stage, which is stage 4 -app deploy. You have the branches, right? Let me do it myself.
We're doing the last one.
Stage 4 app deploy. Are you all on this branch? On this again, do the same exercise of copying the Puppet directory into to-do server, so that provisioning happens from there.
So you are in now what you want to do is you're done.
Once in DevOps 101, this is the command that you have to run. cp -r puppet to-do server.
Shouldn't have been there because it just is the branch.
To-do server.
See, it's on the stage 4 deploy, right? Okay. Now
And go into to-do server and run a vagrant app. Did you destroy the earlier machine? It would be good to destroy the earlier machine because otherwise it will add only the incremental changes.
So I check out the previous branch and
Yeah, it is okay. You can check it. You have checked out the latest code, right? Now go into to-do server and do a destroy. That's all right. Do a vagrant destroy. That's not an issue.
So this is setting multiple things, setting Java and
Can we all do a vagrant destroy and do another vagrant app again? So this one pretty much is the final stage, and at the end of it you can actually see the apps hosted on Tomcat. And we'll quickly look at what it is doing underneath very quickly in like 1 minute. Okay. So now I'm doing a vagrant app. I hope there will be some successes here. Do a vagrant app. While it is provisioning, let us take a quick minute to see what is there in the code. Is it okay? All of those who started vagrant app already. Okay. I'm doing a quick walkthrough now. So, as you might have guessed, we have a lot of Puppet modules for each of the things that we are doing. Abu, we want to give a quick break there. I want to walk through the code, whether you have it running or not. If we can spend some time in understanding this, that will make a lot of sense. Okay? Ivy is already waiting at the back actually. Okay, I got it. Okay, so you can see that we are trying to install a lot of things, right? Which means we need to have a lot of Puppet modules. So we have one for Bootstrap, we have already seen, and then one for Java, Tomcat, and so on. Let us quickly go into what is Java doing. Java's class includes another class, and that class is actually specified here, Java install. So Java install is a Puppet class for us, which does a file download as we have discussed, and a package installation, JDK installation. What do we do when we install Java? We do a file download and a package installation, right? So that's what it does, but the file download has some things to it. Because we are downloading from the Oracle site, it actually needs some cookie authentication there. When we do it manually, it says accept license or something. This is the way to do it from command line. So that is about Java. And then Tomcat has got a lot of things in it, because there are different tasks that we want to do with Tomcat. We want to install Tomcat, we want to start it, we want to deploy some web apps into Tomcat. So they are logically divided into different classes and manifests. If you look at install, what does Tomcat installation mean? It means downloading the zip file and then extracting it into a local directory, right? So we are doing a common file download again, exec. Does anybody want to guess what this common file download could be? Is it a built-in resource or a custom resource that we might have written? It's a custom resource, because you do not have this built-in way of doing it, and we are actually repeating this task of downloading from a source multiple times. So we have abstracted it out into a reusable custom type, and that is available in common file download. Common file download actually uses wget, right? That is what we use for downloading. So you can define your own custom resource types in this way. This is like defining a reusable method. Depending on the parameters, it actually behaves differently. So we looked at Java and then we looked at Tomcat, but can we run these resources in random? No, right? We have some dependencies. Like Tomcat actually requires Java to be installed. We need to set that dependency, otherwise when Puppet actually tries to execute, it will set some random order. There is no guarantee that resources that are in one order will be executed in the same order. So to set the dependency, Puppet allows some common parameters, one of which is require. So let us look at how require is used. If I look at Tomcat install, let us say Tomcat start, it requires the JDK package to be installed. Similarly, it requires Tomcat to be extracted. That is only when you can actually go inside the directory and start it, right? So require is a very important concept. This is how package dependencies are set. So we are done with Tomcat, and the final step is to deploy our app itself. Deploying app is again straightforward. We have the wars and the zip files on the file server. We are downloading those files, and then we are extracting them, and then we are actually calling Tomcat deploy resources. Tomcat deploy war and Tomcat deploy site. These are again user-defined types, custom types, which we have defined in Tomcat deploy. That's a very quick walkthrough. I mean, you might want to take a look at it very closely. The idempotence aspect of it, that is when you rerun JDK installation, it does not rerun again because the same package name is used as the title of it. So things like that. Also, another quick thing that I want to talk about is how idempotence is ensured when in exec resources. So only if that condition is met, it is rerun. Okay, so that is pretty much a very quick walkthrough. And how many of us actually got the catalog finished, like this, finished catalog? Okay, 3, 4, cool. Now those, pretty much everybody I believe. Can we access 192, 168, 33, 10, 80, 80? Can somebody tell me where this IP came from? No, that is file share is a different IP firstly. This is the IP that is in the to-do servers. to-do server's vagrant file has this IP. So it is actually, we are accessing the to-do server itself. So to-do server had Tomcat installed on it. 8080 is the port that Tomcat uses by default. And we are accessing to-do server's IP here. If you look at to-do server's vagrant file, that is the IP that we have. 192.168.33.10. Okay. Can we all hit this URL? To-dos.
8080/todos.
8080/todos. Yeah. Are you able to see it here? How many of you saw this empty array? This is the backend, by the way. This is the backend that is going to supply the RESTful web services for creating to-do lists. Right now there are no to-dos, so it's simply returning empty array. How many of you got it? Now can we access? Can we access this URL now? There is a bug here right now. It's not tested. It's there in the browser storage. Don't worry about it. Okay, don't worry about the pending task. There is a bug there. It's using browser storage too. Okay, let me open up a new browser. Okay, sounds good now. Now let us add a new to-do. Add anything, right? DevOps or something. And can you go back to the backend and see if it is working? Do you see something like this? Add something in the front end and see the backend actually use it. If you get it, that's the end of the workshop. I am done. The others are not. Sure. Do list. How many of you got this to work? I mean, you could actually see the backend reflect the changes that you are making here, right? If anybody has any questions or anything, you can stay back. We are open for any questions. But otherwise, from our end, I think we are pretty much done. Due to logistics issue, we are having to have a hard stop here. So all the facilitators maybe. So any closing things that you want to say, Abu, KK, Mukund? We'll take questions after.
So I have something to say very quickly. So this is typically something which we tend to say, okay, it's a dev thing, and we particularly want to make everybody over here learn and understand how the environment is formed. It doesn't matter what role you're playing. You can go ahead and automate all the scripting and make sure the environments basically, at least if I know QAs actually say, okay, that's something which I own, and that's what you can have a control on. And this is probably one way to get started on automating all of what you actually do manually in your day-to-day lives. And that's what we wanted to initiate over here. We hope it was a good introduction. That was our intention over here. From now on, I think if you really are keen on getting started with something like this, you can go ahead and get started with so many other things. It was a very, very basic, simple app that we wanted to get running over here. And yeah, again, we knew we will have very limited time, and we try to explain as much as we can. But anytime you have any questions, you anyway have access to her repository. I think you can ask questions there as well.
Yeah.
But feel free to just get back to us. We'll share our details as well. Thank you very much. Thank you. Thank you.
open. Thank you.
Hey, guys, please gather where we had the track 1. We